Your Azure SQL Firewall is lying to you. While you're relying on static rules and service principles, attackers are already bypassing your perimeter to exploit overprivileged accounts. The legacy assumption that a firewall equals safety is officially broken. Most Azure SQL environments are currently built on a 1990s trust model, operating in a 2026 threat landscape. Your network boundaries are no longer a shield. They've become a blindfold. We are looking at why set-and-forget firewall rules are the primary reason for modern audit failures. In the next 24 minutes, we are dismantling the network perimeter to build an identity-based stronghold. If you don't move beyond static IPs, you aren't just behind the curve, you are the target. But to understand why the firewall is failing, we have to look at the structural decay of the traditional model. The erosion of the static perimeter. The secure network was designed for a world where people knew exactly what they were looking for. You had a server, you had a known IP, you drew a line around it. That assumption is broken. Because today, work doesn't start with navigation, it starts with context. But our SQL firewalls still start with IP ranges. This is the model behind the failure. Static IP whitelisting is a legacy mindset that fails the DORA 2026 compliance test. It assumes that being on the right network makes you trustworthy. But in reality, it does the opposite. It creates a hard shell with a soft, gooey center. The moment an attacker compromises a single workstation on your whitelisted range, the firewall becomes their greatest ally. It stops looking at them. The 2024 Varonis vulnerability proved this flaw isn't just theoretical. Even secure firewall rule names were used for resource destruction. Attackers used T-SQL manipulation to inject malicious parameters into the rule names themselves. When an admin tried to delete what looked like a benign rule in the portal, it triggered the deletion of arbitrary Azure resources. The tool meant to protect the database became the weapon used to destroy the subscription. And yet many organizations are still clinging to the old ways. Basic public IPs and load balancers reached end of life in late 2025. Microsoft gave years of warning, but many architectures haven't moved. They are running on borrowed time, using retired infrastructure to protect live production data. It's the model that's the problem. Then there is the most common shortcut in the portal. The Allow Azure Services checkbox. It's the ultimate illusion of security. You think you're allowing your app service to talk to your database. What you're actually doing is turning off your security for the sake of convenience. That checkbox doesn't just allow your services. It allows any service in the Azure cloud to attempt a connection to your SQL gateway. You've effectively removed the perimeter you spent months configuring. In a world of automated scanning and AI-driven brute force, that's not a configuration. It's an invitation. We are seeing a massive shift in how we define a safe connection. We are moving from a world of where you are to a world of who you are. Context is replacing location. Identity is replacing the IP address. In the old model, if you were inside the VNet, you were trusted. In the new model, the VNet is just a transport layer. The trust is established at the request level. Every query, every login, every time. If you can't prove who is making the request, the network path doesn't matter. Because in reality, the network is already compromised. This erosion of the perimeter isn't a bad thing. It's a necessary evolution. We've spent decades building walls while the attackers were busy stealing the keys. By dismantling the myth of the secure network, we can finally focus on what actually matters: the data and the identities that touch it. Static rules are a shield made of paper in a world of fire. They provide a false sense of security while leaving the front door open to lateral movement. If an attacker gets inside, they stay inside. Because the firewall only looks at the entrance, it doesn't look at the behavior, it doesn't look at the intent. And it certainly doesn't look at the identity. This shift from location to identity leads us to the most dangerous component of your current setup: the service principal. It's the identity model that was supposed to solve our problems. But instead, it created a new kind of crisis, one that never sleeps and one that never expires. The identity crisis of service principals. Service principals were supposed to be our salvation. They were the standard for a world moving toward automation. We needed a way for applications to talk to databases without a human in the middle. So we created these non-human identities. But in our rush to enable scale, we ignored the structural liability we were building. Today, the service principal is the single most dangerous component of your Azure SQL architecture. It isn't because the technology is flawed, it's because the management model is broken. We saw over 23 million secrets leaked on GitHub in 2024 alone. Think about that number. That's 23 million times a developer accidentally pushed a key to a public repository. And most of those were embedded database credentials, connection strings, client secrets, passwords for service principals. In the old model, we treated these secrets like a one-time setup task. You generate the secret, you paste it into the config file, you forget about it. But the threat landscape doesn't forget. Traditional service principals hold standing, indefinite privileges that never sleep. They don't have working hours. They don't have MFA prompts that a human can ignore. If an attacker finds that secret, they don't just get access. They get persistent silent access that looks exactly like legitimate application traffic. This leads us to the silent killers of Azure SQL security: orphaned credentials. These are identities that outlive their projects. The developer leaves. The application is decommissioned. but the service principal remains in Entra ID, and it still has DB owner rights on your production SQL instance. It's a ghost in the machine. A dormant account with high privileged access, just waiting for a token validation failure like CVE 2025-55241 to be exploited. That specific vulnerability proved that even global admin tokens can be impersonated. If an attacker can impersonate an identity that governs your service principals, your entire SQL estate is gone. The 2026 mandate is now clear. You must eliminate SQL authentication passwords entirely. The industry is moving toward a passwordless baseline. If your application still uses a connection string with a password, you have an unexploded bomb in your code. It's only a matter of time before that secret ends up in a log file, a backup, or a GitHub repo. The solution isn't better secret rotation. The solution is removing the secret from the equation. Managed identities are the only way to achieve a zero-standing privilege posture. Whether it's system-assigned or user-assigned, the managed identity removes the human element of credential management. There is no secret to leak. The password is handled by the Azure infrastructure itself. It's short-lived, it's automatically rotated. And most importantly, it's bound to the resource. An attacker can't just steal a managed identity secret and use it from their laptop. They would have to compromise the specific app service or function that the identity is bound to. This drastically reduces the blast radius of a credential compromise. But many architects hesitate. They worry about the complexity of migrating legacy apps. They think it's easier to just keep rotating passwords. But rotation is just a treadmill that never ends. It's a manual process in an automated world. And every manual process is a failure point. By shifting to managed identities, you aren't just improving security, you're improving operational resilience. You no longer have production outages because a service principal secret expired at 3 a.m. on a Sunday. You no longer have to worry about where your developers are storing their keys. The identity becomes a verifiable structural part of the workload. It's the first step in moving from trusting the network to verifying the identity. Removing the passwords is step one, but the real control happens when we change how we grant access in real time. We need to move beyond always-on privileges, because even a managed identity shouldn't have access when it isn't working. Just in time. The end of standing privileges. Standing privileges are the roadmap attackers use for lateral movement. In most Azure SQL environments today, if you look at the SIS, database role members table, you'll see a list of accounts that have permanent 24/7 access to your most sensitive data. These are your DBAs, your developers, your automated maintenance scripts. They have the keys to the kingdom while they're sleeping. They have them while they're on vacation. They even have them while they're checking their personal email on a compromised home network. This is the definition of excessive risk. It's a model that assumes that because you needed access yesterday, you should have it forever. But in a zero-trust world, forever is the enemy. We need to shift to a model where privileges only exist when there is a documented, verified intent to use them. This is where just-in-time access, or JIT, changes the game. By leveraging Microsoft Entra privileged identity management, you can reduce your exposure window from forever to a matter of hours. Think about the math of risk. If an admin account is compromised and it has standing DB owner rights, the attacker has an infinite window to exfiltrate data. But if that same admin is only eligible for the role, the attacker has nothing. They have a credential with zero permissions. To get to the data, they would have to trigger an activation request. That request requires a justification. It requires multi-factor authentication. And in high-security environments, it requires a second human to hit the approve button. The window of opportunity shrinks from 8,760 hours a year to perhaps 4. That is a 99.9% reduction in your attack surface. Implementing this for Azure SQL used to be a manual nightmare of T-SQL scripts and scheduled jobs, but the 2025 PIM enhancements have streamlined the process through PIM-enabled groups. You no longer map individual users directly to SQL roles. Instead, you map an Entra security group to a database role like DBA data reader or DBA owner. The group is empty by default. When an engineer needs to troubleshoot a production issue, they activate their eligibility for that group. They are added to the group for a fixed duration, say 2 hours. Azure SQL recognizes the group membership and the engineer gets to work. The moment that 2-hour timer hits 0, Entra ID removes them from the group. Their access vanishes. The sleeping giant of their privileged account is put back to bed. This isn't just for humans. We are moving toward a world where high-privilege automation follows the same pattern. Why should your deployment pipeline have permanent write access to your production schema? It shouldn't. It should request JIT access at the start of the deployment and lose it the moment the pipeline completes. This prevents a compromised CI/CD runner from becoming a gateway for a total database takeover, and the system is getting smarter. The latest PIM enhancements now include AI-driven risk scoring. If an activation request comes from an anomalous location or a device that doesn't meet your compliance baseline, the system can auto-reject it. It moves us from a model of eligible means always available to a model of verified intent. You have to prove you are who you say you are on a device we trust for a reason we accept. Without JIT, a single compromised admin account represents a total tenant takeover. With JIT, it's just a failed request in an audit log. But even with JIT, how do we ensure that the data itself is segmented within the environment? How do we stop an identity from seeing things it has no business touching? Access is only half the battle. The other half is isolation. Identity-based microsegmentation. Microsegmentation is the evolution of the software-defined perimeter. In the old world, we segmented networks using VLANs and subnets. If you wanted to isolate a database, you put it in a different subnet and managed it with a network security group. But that approach is blind to the modern reality of lateral movement. Network-level controls only care about the IP address. They don't care about the workload. If an attacker jumps the fence into your production subnet, they can see every database sitting there. They can scan ports. They can map the environment. This is where east-west traffic becomes the primary battleground. In 2026, the battle isn't won at the edge of the network. It's won or lost inside the data center. We are moving away from segmenting by infrastructure. We are segmenting by workload identity. This is identity-based microsegmentation. Instead of a firewall rule that says subnet A can talk to subnet B, we use policies that say app service identity X can talk to SQL instance Y. The network path becomes irrelevant. The identity is the only thing that unlocks the connection. By using user-assigned managed identities as your primary identities, you can create granular workload-specific policies. You can ensure that your HR application's identity can only see the HR database, even if it's sitting on the same logical server as the finance data. This level of isolation is impossible with traditional firewall rules, but implementing this requires a shift in how we deploy security. You cannot just turn on microsegmentation and hope for the best. If you do, you will break your applications. This is why we use the monitor mode principle. Before you enforce a single segment, you must baseline your SQL traffic for a minimum of 2 to 4 weeks. You need to see the legitimate traffic patterns. You need to identify every service account, every reporting tool, and every maintenance script that touches that database. During this period, the system logs every connection attempt that would have been blocked. You analyze the false positives. You refine the identity-based rules. Only when you have zero unexplained denials do you move to enforcement. This iterative approach is what separates a successful zero-trust migration from a production outage. Identity-based segmentation determines more than just who can connect. It determines exactly which SQL objects they are allowed to see. By binding the identity to specific database roles and using features like row-level security, you can ensure that even a successful connection only yields the data necessary for that specific transaction. This is the ultimate goal of the software-defined perimeter. We are shrinking the perimeter until it wraps around a single identity and a single workload. The impact of this shift is massive. Benchmarks from 2026 show that identity-based segmentation cuts breach containment time by 70%. Why? Because when an identity is compromised, the attacker is trapped in a tiny box. They can't scan the network for other databases. They can't use the SQL connection to move laterally to other services. The identity they stole only has one valid path. And the moment they try to deviate from that path, the system flags it as an anomaly. We are making the environment hostile to the intruder. We are making every step they take a potential tripwire. This level of granularity is essential, especially when we consider the new wave of AI tools that are being integrated into our environments. AI tools don't just use data, they discover it. And if your segmentation is weak, they will find things you never intended for them to see. We need to give these tools boundaries, because without microsegmentation, your AI isn't just a helper, it's a high-speed scanner for your most sensitive secrets. The Copilot multiplier, governance in the AI era. Microsoft Copilot doesn't create new permissions. It simply accelerates your existing mistakes. We often think of AI as an external layer, something that sits on top of our data. But in the Azure SQL world, Copilot is an engine that runs on the fuel of your current access model. If that model is leaky, Copilot becomes a supercharged discovery tool for every vulnerability you've ignored. It turns latent permission sprawl into immediate searchable exposure. In the past, an overprivileged user might not have known they had access to the payroll table. They would have had to know the table name. They would have had to write a specific T-SQL query. The friction of the interface acted as a secondary accidental security layer. That friction is gone. Now that same user can simply ask a natural language question. Show me the salary trends for the executive team. Copilot doesn't care that the user shouldn't see that data. It only cares that the user can see it. If the account has the rights, Copilot will fetch the answer in seconds. It bypasses the need for technical knowledge and goes straight to the value. The statistics here are staggering. Recent risk reports show that 83% of sensitive business files in Azure SQL are currently overshared. They are sitting in tables with public or all users access because someone wanted to avoid a support ticket 3 years ago. Copilot knows exactly where those files are. It has indexed the metadata. It understands the relationships between your schemas. This creates what we call the blast radius effect. A single prompt can surface full schemas and sensitive tables that were buried under layers of legacy documentation. It turns a minor oversight into a major breach. We have to stop treating AI governance as a separate project. It is a direct extension of your identity strategy. If you haven't audited your SQL permissions, deploying Copilot is like handing an intruder a high-speed scanner. You are giving the AI the keys to a house where the internal doors are all unlocked. To fix this, we have to implement row-level security and ledger tables. We need to give Copilot the boundaries it lacks by default. Row-level security ensures that even if the AI runs a broad query, it only sees the specific rows that the user is authorized to view. It acts as a filter at the database engine level. It doesn't matter how clever the prompt is. If the identity doesn't have the row level right, the data doesn't exist for that session. Ledger tables add another layer of structural integrity. They provide a blockchain-inspired, tamper-proof history of every change made to your data. In an era where AI can generate and modify content at scale, knowing the exact provenance of a record is critical. You need to be able to prove that a specific value hasn't been hallucinated or manipulated. The ledger provides that verifiable truth, but these tools are only effective if they are part of a broader governance framework. You must baseline your permissions before the AI starts discovery. Use Microsoft Purview to map your sensitive SQL objects. Identify the crown jewels of your data estate, and then apply the microsegmentation principles we discussed. If a user doesn't need to see financial data for their job, their identity should be blocked from that segment entirely. This prevents Copilot from even acknowledging the existence of those tables during a session. We are moving into an era where good enough security is a liability. The speed of AI demands a level of precision that legacy models can't provide. If you rely on the user to do the right thing, you've already lost. The system must enforce the right thing through structural constraints, because in the AI era, visibility is the greatest risk, and the only way to manage that risk is through granular identity-based control. The 2026 audit trap and compliance reality. All of these technical shifts serve one master: the new aggressive regulatory landscape. DORA 2026 has changed the game for every architect working in the cloud. The days of relying on vendor attestations are over. Regulators no longer care that Microsoft has a SOC 2 report. They want to see how you are using the platform to ensure resilience. They want regulator-friendly evidence. This means your own test logs, your own exit runbooks, and your own verifiable audit trails. If you can't prove exactly who accessed a specific database record within 30 seconds of an inquiry, you've already failed the audit. The burden of proof has shifted from the provider to the consumer. But there is a technical trap waiting for you in the Azure portal, the 4,000-character truncation trap. Azure SQL audit logs have a physical limit. If your SQL statements or data sensitivity info exceeds 4,000 characters, the log literally cuts off the evidence. The most critical part of the query, the part that proves what was accessed, could be missing from your history. If an auditor sees truncated logs, they don't see a technical limitation. They see a compliance gap. They see a lack of oversight. To avoid this, you must move toward database-level auditing. Server-level auditing is too noisy and too slow for modern requirements. It creates a mountain of data that is impossible to search during an active investigation. Database-level auditing allows you to focus on the specific workloads that matter. It gives you the granularity to meet the DORA requirements for critical functions. Compliance isn't a checkbox anymore. It is a continuous, verifiable operating posture. You need to be able to demonstrate that your identity-based microsegmentation is working in real time. You need to show that your JIT windows are being enforced, and you need to prove that your managed identities are the only ones touching your production data. This requires a shift in how we think about logs. They aren't just for troubleshooting, they are your defense in a regulatory world that is increasingly hostile to trust me security. The 2026 audit isn't a test of your tools, it is a test of your model. If your model is built on static IPs and shared secrets, no amount of logging will save you. The evidence will simply document your failure. But if you've built on identity, the logs become your greatest asset. They provide the structural proof that your environment is resilient, segmented, and secure. The firewall is obsolete because trust is no longer a perimeter, it is a transaction. Your homework? Audit your firewall rules today and identify every connection still using a static password. Start your transition to Entra-only authentication and pilot JIT for your high-privilege roles immediately. If this changed how you think about your data, follow me, Mirko Peters, on LinkedIn. Leave a review for the M365FM podcast. It helps more architects find these structural truths. The legacy network model is broken. It is time for you to rebuild on identity. Every query must be verified, every access must be earned, and every secret must be eliminated. Stop building walls. Start building verifiable trust. This is the future of Azure SQL security.